function actually might look like, or maybe if we want to test to see whether a specific function is injective or not. Okay, so let's have a look at a specific example. Okay, so here's an example, okay, of us testing for injectiveness, injectiveness, if that makes sense. I hope I spelled that right. Okay, don't know whether that e is in there. Okay, but maybe you can verify that is ourselves. Yeah, and leave a comment. Okay, thank you. So let's say let the function f be defined to take natural numbers, okay, and let's just map them natural numbers into the integers, okay, and let that function be defined by, let's say, f of x, okay, f of a domain value, okay, is equal to, let's say it's equal to 3 times x plus 5, okay, and this is for all x's that are elements of the natural numbers, okay. So we've defined the function, we've specified what its domain values are, we've specified what its codomain values are, okay, and we've given an actual implementation of how the function works, okay. So the function takes in values, x's are elements of the natural numbers, so these come from our domain, and what we get back is, we get back 3 times the value that we've input plus 5, if that makes sense. And the question we have is f injective, okay? Is f injective? Okay, that's a question that we have here. Okay, so there's many ways that we can actually do this. Okay, and I suppose if one way that we have defined injectivity, yeah, okay, is we've defined injectivity, okay, injectivity by, let's choose two values that are not equal to each other, and then what does this imply? Does this imply that the two functions are not equal to each other, if that makes sense? An alternative approach that we could do, an alternative definition, I suppose, of an injective function, an alternative definition of an injective function, okay, would be that if f of some value is actually, if f of x1 is actually equal to f of f2, well then that should imply that x1 is equal to x2. That's an alternative definition. So let's actually, it's probably a little bit better to try it that way, okay? So let x1 and x2 be elements of the natural numbers, okay? So let us just choose two natural numbers, okay? We don't know whether they're similar, whether they're the same, or whether they're different, but we're just choosing two natural numbers from our domain, okay? They could be the same, they could be different, okay? And let's say, for argument's sake, let f of x1 equal f of x2, okay? So let's assume that the two numbers are mapped to the same point, okay? So we're assuming, okay, we're assuming the two elements of our domain, okay, are mapped to the same point, to the same point in our range, okay? So that's the actual values that are, that's the actual place where our values are actually mapped into, if that makes sense. So let's assume that that is the case. Well, what does this imply? Well, this implies then, so if f of x1 is equal to f of x2, well, let's look at the prototype here of the function, how it actually works. Well, then that implies that 3 times x1 plus 5 must be equal to 3 times x2 plus 5, if you see what's going on here, okay? Now what does that imply? Well, then that implies that 3 times x1 must be equal to 3 times x2, which implies that x1 must be equal to x2, okay? Which is what we require, okay? What we require is this, is that if f of x1 equals f of x2, okay, well then this should imply, okay, that x1 is equal to x2. That's what we mean by injective, okay? Okay. The other thing is, if x1 equals x2, well then this implies that f of x1 should be equal to f of x2, okay? That's what we also mean by injective, okay? So we're just doing them, it's just an alternative approach. What I did here in this particular situation was we took it from, I suppose, from the domain, from the codomain, and we worked backwards to the actual domain values. We could choose the domain values, okay? We could choose the domain values, and we could work forwards, if that makes sense. Yeah. So if you see what's going on here, this is really important. Actually, I suppose there's a little bit of a difference. I've actually made a mistake here. It says if f of x, if x1 is not equal to x2, well then this implies that f of x1 should not be equal to f of x2. Okay, that's the alternative approach, and that was the definition that I provided earlier on. Okay. So that's how we test to see whether a function is injective or not. Okay, I like to use this approach here. Okay, which is a little bit sometimes it's a little bit handier to do. Okay, is let's just choose two values from our domain. Let's set the functions under them particular mappings. Yeah, let's map those two values, okay, to where they would go in the range. That's f of x1, f of x2. Okay, let's set them equal, and let's see what the consequences is of them being equal. And in this case here, what we have is that x1 is equal to x2. So you can actually see that we assume that f of x1 is equal to f of x2. This is this piece. Well, then through the deduction, what we end up with is x1 is equal to x2, which is then, this implies x1 is equal to x2. That's exactly what we have here. So hence, this function is injective. It is an injective function, if that makes sense. Okay, so that's an example of how we test to see whether a function is injective or not. Okay guys, once again, this was Jonathan Lambert with the Mathematics Development and Support Service at National College of Ireland, and I hope that this video was in some way helpful, and thank you for watching. Okay, bye bye.